In this video, we're going to be solving some parametric trigonometric problems. So a particle moves in the plane according to the parametric equations x of t is equal to 6 sine 2t, y of t is equal to 4, 1 minus cosine 2t, 0 is less than or equal to t, is less than or equal to 2 pi. At what times t does the particle satisfy? X squared plus y minus 4 squared is equal to 16. Give all the values of t in the interval of 0 is less than or equal to t is less than or equal to 2 pi. Our first step is we are going to take x is equal to 6 sine 2t, and we're going to substitute the parametric equation. So this is going to become now for y. So now from here, if we square both sides, now we're going to substitute this into this equation. So that expression will become 36 sine squared 2t plus 16 cosine squared 2t. That is x squared. And y minus 4 squared is equal to this component. This is equal to 16. We can use our Pythagorean identity. But we can rearrange this for cosine squared t. And here we will use the version where our input is 2t instead of t. The Pythagorean identity holds true as long as the angle that you're using is the same for each of the trig functions inside of the identity. After this, you can solve. So we are going to examine what our input is. This is equal to theta. Theta is equal to 2t, and this is equal to n pi. Therefore, if you solve for what t is equal to n pi divided by 2. Now, our restriction here is 0 is less than or equal to t is less than or equal to 2 pi. So our value has to be less than or equal to these values or in between it. So our values are going to be t is equal to 0, now let's do another problem. A particle moves according to x of t is equal to 4 sine 2t, y of t is equal to 3 times 1 minus cosine 2t, for 0 is less than or equal to t is less than or equal to 2 pi. Find all the values of t such that x squared plus y minus 3 squared is equal to 9. Our first step is we want to sub the parametric equations. So we know that x is equal to 4 sine 2t. So what we want to do is we want to get it to mimic something that is inside of here. We want to get that x squared, and we can best do this by taking our entire expression and squaring both sides, giving us x squared is equal to 16 sine squared 2t. Now we have to do the same for y of t. Y of t, we have 1 minus cosine 2 of t. Now what we can do here is we can distribute. We get 3 minus 3 cosine 2 of t, 2 times t. So after this, we would just subtract 3 to get our similar form, and we can see it come together. After this, we just square it like we did before, and we get y minus 3 squared is equal to 9 cosine squared 2t. And now we can see that we have got our forms that we wanted. So if we substitute this into the equation, we have 16 sine squared 2t, it plus 9 cosine squared 2t is equal to 9. After this, we'll use the Pythagorean identity. So we know that cosine squared 2t is equal to 1 minus sine squared 2t. So if we substitute that in here, we have 16 sine squared 2t plus 9, 1 minus sine squared 2t. What we were substituting was, we see this cosine squared 2t. We can replace this with this entire string right here. And this is equal to 9. After this, you would just distribute 16 sine squared 2t plus 9 minus 9 sine squared 2t is equal to 9. You can combine like terms now. Plus 9 is equal to 9. And those 9's cancel out, therefore 7 sine squared 2t is equal to 0. Those 7's cancel out. And if you take the root of both sides, that cancels out as well. Now, theta is equal to 2t. So if theta is equal to 2t and that is equal to n pi, t is equal to n, divide both sides by 2. T is equal to n pi over 2. Now we're going to list the values that are in our interval. So that's from 0 to 2 pi. So we have to ask ourselves, when does this expression hold true? When is sine of an angle equal to 0? So or when does this repeat? T is equal to your number times pi divided by 2. Now t is going to equal to 0, pi over 2, pi, 3 pi over 2, and 2 pi. So this is your final answer. A particle moves according to x of t is equal to 5 sine 2t, y of t is equal to 4 times 1 minus cosine 2t for 0 is less than or equal to t is less than or equal to 2 pi. Find all the values of t such that x squared plus y minus 4 squared is equal to 16. So what we can do here again is we can immediately square both of our sides here, and we're going to get x squared is equal to 25 sine squared 2 of t. And here we can rearrange this by distributing that, and we would get y is equal to 4 minus 4 cosine 2 of t. Now you would subtract your 4, and you have y minus 4 is equal to negative 4 cosine 2t. Now you just square like you did before, and you are going to get y minus 4 squared is equal to 16 cosine squared 2 of t. Now you would just substitute these values into here. So you would take your x squared, and you would take your y minus 4 squared, substitute those in, and your answer is going to be, for here, 25 sine squared 2t plus 16 cosine squared 2t is equal to 16. Cosine squared 2t is equal to 1 minus sine squared 2t. So 25 squared 2t plus 16. Now we can replace that cosine squared 2t like we have been doing. And that is 1 minus sine squared 2t is equal to 16. Now you just distribute, and that is going to be 9 sine squared 2t plus 16 is equal to 16. 16s will cancel out, and if you divide both sides by 9, that will cancel out because that's going to be equal to, well, let's show that in our next step because that is kind of a lot. There's a 9 there, and this is equal to 0 over 9. Nothing will happen. Sine squared t is equal to 0. Root, nothing will happen. Sine of, that is 2t. This is 2t, and this is of 2t is equal to 0. Now 2t is equal to, that is your theta, is equal to n pi. Therefore, if you divide both sides by 2, t is equal to n pi over 2. Now your values in 0 less than or equal to t less than or equal to 2 pi. That is 0 pi over 2 pi, 3 pi over 2, 2 pi. A particle moves according to x of t is equal to 3 sine 2 of t, y of t is equal to 5, 1 minus cosine 2 of t. Again, we do this similar process that we have been doing. You're going to try to match. So this is going to be equal to x squared, 9 sine squared 2 of t, 2 times t. And here you are going to distribute, and you get y is equal to 5 minus 5 cosine 2t, and you subtract your 5. So after that, you get y minus 5 is equal to negative 5 cosine 2t. So you can square both sides, and you get that y minus 5 squared is equal to 25 cosine squared 2t equal to 25. So cosine squared 2 times t is equal to 1 minus sine squared 2t. Now you just substitute in 9 sine squared 2t plus 25, 1 minus sine squared 2t is equal to 25. Now you can just distribute here, and you have your solution, which will become 25. So this is going to be negative 16 sine squared 2t plus 25. Actually, 9 sine squared 2t plus 25 minus 25 sine squared 2t is equal to 25. Negative 16 sine squared 2t plus 25 is equal to 25. Negative 16 sine squared 2t is equal to 0. You can divide both sides by negative 16. Sine squared 2t is equal to 0. The root of both sides, and sine 2t is equal to 0. Sine, now that's your theta. 2t is equal to n pi. T is equal to n pi over 2. And it's the same values as above for t. A particle moves according to these. It's basically the same format again. So let's do this. Substitute. Distribute after we Three over 8 is So we're going to let alpha this, if in your calculator, is 0.6591. So because we have 2t, we have 0.4 pi instead of 2 pi. And you're just gonna have to divide everything by 2. So we're taking this whole entire set and we're gonna divide all that by 2. And that is a really long answer, so we'll just leave it as that. A particle moves according to this. So this is 36 cosine squared 2t. So plus, we'll do that down here. Is equal to 36. These are going to be the same values.